Hi, welcome to LeetCode. Today I'm going to discuss LeetCode problem 2707. Extra characters in a string. So you are given a zero index string S and a dictionary of words dictionary. You have to break S into one or more non-overlapping substrings such that each substring is present in dictionary. There may be some extra characters in S which are not present in any of the substrings. So return the minimum number of extra characters left over if you break up S optimally. So for this example one, so the input string is actually LeetCode. Okay, dictionary words are LeetCode. Okay, so we have to break the LeetCode the input string such that we actually the extra characters will be the minimum. Okay, so how many ways actually I can actually break this LeetCode? So first of all, one word can be L, next can be LE, then Lee, then Leet, then Leets, then Leets C. In this way, right? Similarly, if we break here actually L, then new character next word can be E, then EE, then EET. In this way, right? So I have to actually check that if we break the in this way any word. Suppose we actually break this. Suppose in Leets try to break. So I have to check that this word actually valid or not. How actually check? These words have to be present in the dictionary string. I will check, okay, leads doesn't friend it not present in the dictionary string dictionary array. So this is not a valid word. So I will check L. Can I break this? No, because L is not present in the dictionary. Lee, Ellie not present. Similarly, Lee is not present. Leet is present. Yes, I can break this. So I'll go to the next possible. Like I have already break this word from this LeetCode. Next string are present is actually only S code, right? Remaining string. So I have to divide this. How? S SC SCO SCOD SCODE. I'll check this is valid. No. SC is valid. No. SCO no. SCOD no, because this string is not present. This is not present, right? So this is one possible that this actually our extra character. I have to actually I have to actually count this. So I will just what I will do, I will just actually skip this. What will be the then our actually number of extra character will be now 1 because I actually skipping this S. Now remaining string will be code. Then what is the how many ways so I can actually break this word? C CO COD CODE. I'll check this is valid. No. CO valid. No. COD is valid. No. COD is valid. Yes. This code actually present. Right. So this is actually valid word. So if I break this in this way, what is actually extra character number of extra characters is 1. Right. That is the S that we actually skipped. So suppose we actually break this till for this breakup actually I actually checked. Now next breakup next what is possible leads that is present in the dictionary. No, leads SC not present. So in this actually I have to check. Okay, so now let's see this example. This is the the LeetCode, the input string. This is the input string and the dictionary words are leet, code and S. So in this way, first I have to check from left to right what is the word actually I can actually first found in the dictionary leet, right? Next is found in the S. Next is code. So I have checked the all character are present in our dictionary and valid substring non-overlapping. They mentioned that this should be non-overlapping extra non-overlapping substring into one or more non-overlapping substrings such that so here actually no one actually overlapping, all are actually different. Leet then S then code. So for this combination, what is actually number of extra character? 0. So this will be our answer, right? So for now, for this example, input is the LeetCode again, same, but dictionary what actually changed. This actually Leet and only code are present. That time only what will happen, that we have already explained the example one. In that similar way, like I will match actually, I got the word Leet. Then I'll check S is present. No, this is actually not present. I have to skip this. So this actually count will be 1 now. Now we get next word actually code. Code is present. Yes, code is present. Right. So what is the for this approach, the number of actually extra characters is 1. Now how actually, what is the worst case? Worst case is we have to skip all the characters. That is the maximum number of maximum extra characters is equal to n. N means the length of input string, right? So all character we have to skip. That is actually maximum answer possible. Then we have to actually optimize this. So before going to the actually next word, we can actually check that this, if we actually skip this, just go to the next example, LeetCode. Okay. Now we have to find the first of all, what is the maximum answer possible, length of the input string. This is the worst case. So what is the length of the input string? 1 2 3 4 5 6 7 8 9. So this is our actually maximum answer possible. All actually we have actually skipped all the characters. Now we have to minimize this answer. So first of all, what actually we got? Lee. Then what is the character actually got? T. There is no string word present in the dictionary that is actually starting with T. So T will be skipped. So for this will be count 1. Then there is no string starting with S. Then this will be also skipped. Count is again 1. Now remaining stage is code. Then we got actually code in the dictionary. So this actually, for this approach, what is the actually number of characters actually extra? 2, right? So our answer will be currently 2, because 2 is less than 9, so it will be modified to 2. Any other combination we actually got, you can check that. If we actually take this Leet, then we get, then what will be the combination? So we take actually Leet, then extra character we have to, there is no string starting with S. We have actually skipped this. Next is actually code. We got actually what code, so only 1 character actually skipped. So for this combination, our number of actually extra character is 1. So this will be modified with 1. So our final answer is 1. So you have to check actually all combination, like whenever we got any character, any word in the dictionary, then still we have to actually check for the next word also, next possible word, because here actually you can check we got actually Lee, but if we take actually Leet, actually that time actually give us the minimum answer. That's why we also check to the next word also, right? So what you have to do, we'll actually check all possible actually word. Okay, like actually here actually Lee, L, then Lee, then Leet, then Leets, then Leets C, in this all characters. So that actually we'll check all the combination, then we actually find out what is the minimum, right? So that's why we actually there will be a for loop that it will start from, like it will generate the LE, that is a for loop starting from I is equal to 0, then I less than n. It will generate this all the possible words starting with L, right? Whenever we will break a string, that is the next character, next index will be the starting index of the next word. Like if we actually break on the Lee, then the next string is E T C O D, right? This is the possible remaining string. From this actually we can check E T ETS code, right? So just go to actually code, that is actually more easy actually. I think it is clear, right? The explanation that how it's working. I actually explained 3 examples also, like how it give us the minimum. Here actually this is the more important, I think, because here actually you can check we got actually 1 word before, before we got the minimum answer. So that's why we have to check all the combination. If it is clear, then please, I will actually give a hints that use the actual recursive function and then take the minimum value in global or any variable. You can also store the global minimum answer. Okay. So just show actually code now. And if you like the explanation, please like the video. And if you not yet subscribe the channel, please subscribe it. Now come to this code. So this is our main function, main minimum extra character. It will give us the input string and the a dictionary array or actually contain the word. Now this dp will come actually later. First of all, we will take a map. Why actually take a map or set? Why actually set? Set actually help us to check that like we're actually checking, right, that l e any word actually present is a valid word or not, present in the dictionary or not. So if we check each time iteratively means the character by character, that will actually give us the, like, if there are n character in the dictionary, for n character for there is n word, then for n word if we have to check each word like length w, that will take n into w time. So that will give us the brute force. It will take more time. So that's why if we use set here, that actually give us directly that suppose any word, it will give us in constant time that this word is present or not, right? So that's why we have actually used this set here to optimally find that this any word actually present in the dictionary or not, right? So we have inserted all the word from dictionary to the set, stored in the set. Okay, now we are calling this recursive function solve, where we are passing the input string and the starting index is 0. Now what we are actually doing here, that whenever our index is greater than equals to string dot size, that means what, we have reached the input string, end of the input string leet's code. So if our I is at the end, that means what, we have already iterated the input string, that means there is no extra character possible because we have already reached the end. So that's why return 0 that time. Okay, else what I will check, this dp will come later actually. What is dp? Now we'll check what, this is the worst case. Worst case mean what, we are skipping this current character. That time what will happen, our number of extra character will be 1 plus the remaining string actually will return. Then again you can say 1 for this current character we are skipping. This is the worst case, like, and we are calling this solve function again recursively, where we are passing input string and the index we are passing index plus 1 because we have already skipped the current index. So the next starting index will be index plus 1, right? And else what will happen, we will check all the combination, like for l, le, lee, laet. So that's how you can check I is equal to starting from 1 and index plus I less than equal to s dot size. That means 1. Here actually I means the number of character we are taking, like here actually I means 1, here I means 2 because there are 2 character. Here actually I equals to 3 because there are 3 character, l double e. So that's why how much actually what is the index, what is the length can go index, what is the index current index plus length, which will be length that should be less than equal to input string s dot size, right, and I plus plus. So that's why we're creating a substring that will return index, starting index, and that many character, like I is equal to 1. So and starting index is 0, 0, 1, what will return l, 0, 2, what will return le. Okay, so that's why one string I will get. I will check that string, that word, like any word like l is present in the set or not, is stated to find. If it is present, that means what, it will not equal to end, it will present. Then I will again call this recursively that function again, that solve function, where passing this s and the index plus I. Index plus I means what, the next available index, right? Index plus I, you can check I is equal to 0, I is equal to 1 and index is equal to 0. So next available index will be what, if we found any word l that is present in a dictionary means set. So next available index should be id will be 1 because we have already taken 1 character. So that's why I index plus I. Okay, and then we take the minimum value. Minimum value means what, this is the case when we actually skip the current character, current index, then whatever the actually number of extra character we got, and if we take the current word, like what is present in the set, and then what is the minimum answer actually we got, then whatever the minimum that will actually, our final minimum value actually we have to minimize this, so ultimate minimum value we will have to store, so that actually we will return. Okay, now this part actually we are actually stored in a dp. Why actually you have to call a dp vector here? Actually you can check, this is calling it recursively, right? We're calling this solve function recursively. Recursively means what? Like suppose LEET COD, right? Now we break, suppose in leet's code, we break in leet, then we got this word, and suppose our current string is code. Okay, now what will the approach? I will skip this current character is, and the remaining string is code. Then what we'll check? We'll check what is the we have already actually suppose calculated the minimum number of characters extra in this string, input string code. Suppose now we actually found this. Okay, this character is not present. This s is there is, we have skipped this again. Okay, now we actually calculated all the actually value. The what is the minimum extra character? Okay, for this breakup like leet, then s is extra, then code. Okay, 1. Okay, now again we actually what will call, we got a match of the word lee. Okay, then extra character is ts, then the input string is code. Now you can check actually this lee, this actually matched. Okay, then t, if I take as an extra character, then the remaining string will be s code, that we already calculated in this situation, right? That we have already calculated. You can check when we break up this break this word in leet plus s code, that we have already calculated the what is the minimum number of actually extra character present in the s code, that we already store against this, and again we are now actually going to calculate this, so this will be actually a duplicacy. So that's why we will actually return this actually we already calculated, not how actually it will get the starting index. It will actually return that this index we have already calculated or not. This index means what? Starting index, and always the ending index, we actually passing this, right? So that's why I will check this character, this index actually calculated or not. Calculated or not, how actually we will know that? If it is not equal to -1, that means we have already calculated this. Else it is 0 means there is no extra character. Else it will be suppose positive value more than 0, greater than 0, that actually check that this many character actually extra, but it should not be -1, because at least there will be 0, or there is at least one actually extra character, so that will be not equal to -1. That time return this dp of the what is the index value, store and that dp vector, and at the end also return store this before return from this function, store this into the current index, that this mean actually like here actually s code. Before going to return that 1, we'll actually store this here actually, this index. What is the index? 1 2 3 4 5 0 let's code 1 2 3 4 5 6 7 8 9. So 0 1 2 3 4 5 6 7 8 9. So what is the index of the s? 0 1 2 3 4 5. So 4 index I will store this is actually 1, right? So there is an extra 1 character present in the starting index from s code. Now in the second time whenever we'll come to this again s code, I will check this index actually what is the value stored in the here actually 1. So I'll directly return from here that there is actually 1 actually extra character present. I think it's clear, right? If it is clear, then please like the video, and if you have any doubt you can actually comment on this, and any suggestion also you can actually give this in the comment box. I will actually check that. And thank you. Keep coding.